Good evening everyone. Today I will be discussing on evaporator, which is the heart of the food processing industry. Now in this discussion I will basically cover what is evaporation and what is evaporator. Okay, as you know, evaporation means the evaporating the water from a solution. Okay, so evaporation is defined as the removal of the solvent from a solution and to concentrate the non-volatile solute in a solution. Okay, so evaporation is used in food processing industry mainly to concentrate the solution by removing the water, which is nothing but the solvent, as almost all the food materials contain 80 to 95% water, so which is the main solvent. If we remove the solvent from a solution, so we will get the more solute and we will get the concentrated solution. And there is a wide application of evaporation process in food processing industry for concentration purposes. Okay, so evaporation is used. There are lot of advantages and not disadvantages. There are a lot of advantages of evaporation. So why evaporation is done? Evaporation, as the mass and volume of the food product is reduced, so we can reduce the storage cost, transportation cost, as well as we reduce the water activity by removing the water from the solution. So it is also a preservation technique by which we can increase the shelf life of the food material. It also increases the microbial chemical inactivation rate, and it also provides the food materials microbial stability, means it increases the thermal inactivation rate, which will cause microbial degradation. Okay, and evaporation can be used as a preparation technique before different unit operations like drying. If we want to go for drying, before drying, some food materials are pre-concentrated. Just like if we want to get milk powder from liquid milk cannot be dried directly. So for getting the powder, we have to concentrate it by evaporator, and after that we will get the powder. Similarly, for getting the concentrated tomato ketchup, tomato puree, we have to use the evaporator. Now evaporation is the main application. Evaporation has main application in food processing industry for concentration purposes. So what is the components? What are the components of evaporator? There are main components of the evaporator is calendia, which is nothing but the heat exchanger. If we go for a what is one whiteboard, if I go for this, then you can see. So this is known as the single effect evaporator, which is why it is known as the single effect, because if you look at this, this is known as the calendia. 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 What is calendia? Calendia is a cylindrical cell. This is known as the cylindrical cell. This is the cylindrical cell inside which a large number of tubes are arranged. Either it may be horizontally or it may be vertically, through which the liquid foods will be flowing, which is to be concentrated. And outside the tubes, there will be steam will be flowing. So there will be heat exchange between the steam as well as the liquid food material through a tube cell or tube wall. So for this reason, this calendia is nothing but a heat exchanger through which heat will be transferred from the liquid food material or from the steam to liquid food material. By condensing steam, you will get the heat will be transferred to the liquid foods, and from the liquid foods the water will be evaporated, and this is there will be vapor separator which will be separating. I will be coming later. So this is the vapor, and here from here we will get the concentrated product. Okay, similarly if we look at this, now why it is known as the single effect? This is the single effect. Why it is single effect? Single because there is only one calendia is used inside in a evaporator for concentration purposes. If more than one calendia is used, then now depending on the number of calendia it is named. If it is 2 calendias, then it will be known as the double effect. If it is 3 calendias are used, then it will be triple effect. Okay, so depending on the number of calendias, evaporators are classified on different double effect, triple effect, quadruple effect. Okay, now if we go for some material and energy balance of an evaporator, single effect evaporator, then this is the single effect evaporator. Okay, now this is the calendia. Here feed is entering. Suppose this is the feed is entering inside the calendia, and this is heat exchanger inside which steam is entering, and whenever steam will be delivering the latent heat, so it will be converted into the condensate. Condensate is nothing but the hot water having same temperature, because it will release the latent heat. So latent heat, whenever it will be releasing, so same temperature it will, the temperature of steam and the temperature of the condensate, that will remain same, and same amount of whatever the amount of steam will be entering into the heat exchanger, same amount of condensate will also get. Means S will be equal to, S is the amount of steam entering, so C will be the amount of condensate we are getting. So S will be equal to the C. Okay, and from here we will getting the, from the bottom of the evaporator or calendia we will get the concentrated product. If P is the concentrated product, amount of concentrated product we are getting, and from the F is the amount of feed entering. So, and from the vapor separator, from the upper portion of the vapor separator, this is the known as the vapor separator, we will get the vapor, which is the amount of vapor is V. So if we do material balance, overall material balance, so we can write, what we can write, what is the input? Input is F plus S, this is the input, will be equal to the output. What will be the output? Output is vapor, condensate and product. So we can write V plus C plus P. This is the output. Okay. Now this is the overall material balance. Now if we go for the mass balance or solid balance. Solid means component balance. How much component remains inside the feed or inside the product, inside the steam. So what is the component of feed? Feed is the solid material. Solid material present in the feed, solid material present in the product. And solid material is present in the steam. There is no solid material present in the steam. There is no solid material present in the condensate, because these are the steam means vapor, pure vapor, and condensate means hot water. So it will not contain any solid material. Vapor is also solid material. It will not also contain any solid material. So if we take fraction of the solid material, fraction of the solid material present in the feed is XF. Fraction of the solid material present in the feed is XF, and fraction of the solid material present in the product, concentrated product, is XP. So solid material balance we can write, because vapor, steam and condensate does not contain any solid material. So we can write for solid balance F into XF is equal to P into XP, or we can write P is equal to concentrated product will be F into XF by XP. Okay. From there you can calculate how much product, concentrated product you can get if you know the feed rate, if you know the solid material percentage or solid material content in feed and solid material content in product. And another equation you can also get from this, as from here F is equal to material balance equation. As we know, F plus S is equal to V plus C plus P, and as I have told, S is equal to C. Why S is equal to C? S is equal to C. Amount of steam entering will be equal to the amount of condensate produced, because same amount of steam will be converted into the same amount of condensate by releasing the latent heat of condensation. Okay, so from this overall material balance we can write, so S and C will be cancelled. F is equal to V plus P. F is equal to V plus P, or we can write V is equal to F minus P. How much vapor it will be produced, that you can, and or you can write instead of P, if we put this, so it will write F into XF by XP. XF by XP. So V is equal to, we can write, if we, so all of you have understood all these things. If you have any confusion or any doubt, you can ask me. Okay, because these are the important things which is very much useful for calculation purposes. So V is equal to, we can write, how, what we can write, F into, if I take F common, then we will get F into 1 minus XF by XP. This is the thing. And sometimes this XF or XP by XF, this is known as the circulation ratio. V or R is equal to known as the circulation ratio. Circulation ratio is XP by XF, means solid material present in product product, concentrated product divided by solid material present in feed material. So V is equal to, we can write F into 1 minus, if it is R, so we can write 1 by R. So it will be XF by XP. Okay, so how much vapor, what is the vapor? This is the amount of water evaporated per unit time. So this vapor V also expresses the nominal size of the commercial evaporator. If we want to buy for an industry, so what will be the nomenclature, or we have to use that how much water evaporation will be required per unit time, that we have to tell. Suppose 100 kg per hour or 1000 kg per hour, that is known. So V indicates the size of the evaporator commercial. So V can be calculated by this equation, F into 1 minus 1 by R, where R is the circulation ratio or concentration ratio. This is also known as the concentration ratio. Concentration ratio. Okay. So from this we can calculate. Suppose if we take an example, you will be better understood by this. If you are told in an industry, suppose tomato ketchup industry, that is, suppose 100 kg tomato juice. It is 100 kg tomato juice is concentrated from, suppose, 20-degree bricks to 60-degree bricks. Suppose, what is degree bricks? I think all of you know degree bricks is the amount of, or one, suppose 1 kg of sugar like soluble amount per 100 kg of solution. That is known as the degree bricks, and that is measured by the refractometer. Okay, suppose 100 kg of tomato ketchup or tomato juice is concentrated from 20-degree bricks to 60-degree bricks. So what will be the product of, or what will be the concentrated product, or how much concentrated product you will get if we concentrate 100 kg of tomato juice from 20-degree bricks to 60-degree bricks. So how will you calculate? So here we want P, how much concentrated product. Okay, so P is equal to, I have told P is equal to, what is P? If you look at this, the equation, that P into XP is equal to F into XF. Okay, F into XP, F into XF. So P will be F into XF by XP. Now here F is equal to 100 and XF. What will be the XF? XF is the solid material present in feed. Now what is the solid material present in the feed? Feed material presents, that is 20-degree bricks. Now whenever it will be used in equation, it will be in decimal. So 20-degree means 0.2 divided by, what will be the concentration of the solid material in product? 60-degree bricks. So it will be 0.6. So it will be 100 by 3. So it will be amount 33.33. 33.33 kg almost you will get the concentrated product. Mean whenever the concentrated product you will be getting, that will be in less amount compared to the feed amount. That is the obvious. So this is known as the material and energy balance, which is very much important. And from here you can get, if it is the product, so what will be the vapor produced. So vapor, how will you get it? So feed minus product, that will be the vapor. So 100 minus 33.33, that is 67.67 kg will be the vapor will be produced. Okay, all of you have understood how you calculate amount of vapor or amount of product. Okay, next thing, what will be the energy balance? Similarly, energy balance, for doing in the energy balance, same thing, input is equal to output. How much energy is input, that you have to know. What will be the amount of energy? If we know the enthalpy of the feed, suppose enthalpy of the feed is HF. What is enthalpy? You have to know what is enthalpy. Enthalpy is the heat content, amount of heat content present in the feed material. If it is HF, and unit, what will be the unit? Joule per kg or kilojoule per kg. So this is known actually specific enthalpy. And enthalpy of the steam is capital Hs. This is also unit kilojoule per kg. And if we get V, this enthalpy is, if we suppose HV, and condensate enthalpy is HC, and concentrated product enthalpy is HP. So we can write input, what will be the total energy input, heat energy input to the calendar. So we can write F into HF, this is the feed enthalpy, plus S into HS, this is the input, this is the steam, this is the amount of heat present in the steam, will be equal to the how much heat is going out from the calendar or evaporator, that is V into HV plus C into HC plus P into HP. Now this is the total heat input and total heat output. Now this can be also simplified by putting, instead of C, if we put S, because I have told also earlier what will be the amount of steam is entering, same amount will be converted into the condensate. So if we write F into HF is equal to, or plus S into HS is equal to V into HV plus S into HC plus P into HP. Or we can write similarly here F into HF plus S into HS minus HC is equal to V into HV plus P into HV. Now this HS minus HC, what is this? Can you tell me, any one of you? HS minus HC, what is H? H is the enthalpy of the steam. And what is HC? HC is the enthalpy of the condensate. So this is the minus, means this amount of heat is leaving from the steam, because latent heat is that heat which is released at the same temperature and a phase change will occur. Steam is converted into the liquid water. So this is known as the lambda, means latent heat of condensation of steam. Okay, so we can write F into HF plus S into lambda is equal to V into HV plus P into HP. Okay, so this is the total energy balance what we can write from here. So lambda is the latent heat of condensation of steam. Okay, now another thing you can do, then whenever this is the temperature, actually temperature of the feed is TF we have taken, and temperature of the product will be the same as the temperature of the boiling temperature at which it is entering or temperature at which it is boiling inside the evaporator. And temperature of the vapor is also same as Tv. Tv will be equal to the T1. Okay, because same temperature vapor will be produced. And this P pressure is generally kept lower than the atmospheric pressure inside the calendar. Why? To boil the solution at lower temperature. If we boil the solution at lower temperature, so what will be the low temperature? If we boil at high temperature, so what will happen? Nutritional values, whatever the nutritional ingredients present in the food, that can maybe destroyed. So to intake the nutritional ingredient and to kept that in the food material, it generally evaporator is operated at lower temperature. Generally, we also know that whenever any food material boils, if it contains 90% or 95% water, so if we assume that the boiling point same as water, so it will be at 100 degrees centigrade, the solution of the food material will be boiling. But whenever any food material is boiled at 100 degrees centigrade, then what will happen? Any nutritional food material that can be destroyed. So keep to it to intact or to remain that nutritional ingredients inside the food material, we have to reduce the temperature, or we have to, for increasing the quality attributes of the food material, we have to reduce the temperature inside the, generally it is vacuum is maintained inside the, we know 100 degrees centigrade is the boiling point at 760 or 1 atmospheric pressure, 760 millimeter of Hg. But inside the calendar, it is maintained at about 600, 500, 500. From the steam table, you will get what will be the at corresponding 500 millimeter of Hg. What will be the boiling point? About 70 degrees centigrade or 75 degrees centigrade, it will boil. Okay. So from 100 degrees centigrade, it will be reducing to 70, 60 degrees centigrade boiling. Okay. All of you have understood? Any question? If you have any question, you can ask me or I will proceed. So this is the thing, but one thing, for food material, we have assumed that the boiling point of the food material is same as the boiling point of water, means 100 degrees centigrade. But sometimes what happens, the boiling point of the food material, suppose any salt, if we want to prepare the salt, so due to the dissolved material inside the food material or any solution, not the food material, suppose any solution, if you want to concentrate, due to the dissolved material, the boiling point is reduced, and then this boiling point elevation will occur. So from this, say this is applicable for salt solution, sugar solution, mainly salt solution. It is happening boiling point, sodium salt, calcium salt, magnesium salt. If we want to concentrate, then it will boiling point elevation will occur. This boiling point elevation can be calculated by Sibel's formula. That is also different formula, or there is chart. From boiling point elevation chart we can also calculate. Now one thing, another important thing I want to discuss, that is whenever any, if we increase if it is cold food, suppose the feed temperature is normal ambient temperature, it is entering, suppose TF is 30 degrees centigrade. So what will happen? The amount of energy, maximum steam will be required to reach the temperature of feed material to the boiling point, that is T1. T1 is suppose 70 degrees centigrade. So maximum amount of steam will be required to increase the temperature of feed material from 30 degrees centigrade to 70 degrees centigrade. Then it will boil. So if this feed material is preheated by the whatever the vapor that is coming out by using the mechanical vapor recompressor, then this vapor can be used as a preheater inside the preheater, which will increase the temperature of the feed from 30 degrees centigrade to the boiling temperature. Then this will reduce the energy cost, because in case of evaporator, maintenance cost is mainly the steam cost. If we reduce the steam cost, then we can improve the efficiency of the evaporator. This efficiency of the evaporator actually is measured in terms of one term is there, that is known as the steam economy. Steam economy. What is steam economy? Steam economy is the amount of vapor produced per unit steam consumption, V by S. Generally for single effect evaporator, this is single effect means single calendar. It is for 1 kg vapor production, 1 kg of steam is required. So steam economy is almost 1. But if it is less than 1, then it is steam economies, means by providing or by entering 1 kg of steam, we can produce more amount of the vapor, then it will be better. Means then it is known as the different types of the vapor is used, double effect, triple effect, that can improve the steam economy. How they can improve? By which they can improve, that is, so steam economy can be improved by multiple effect evaporator, that is known as the multiple effect evaporator. So if it is double effect, then it will be double calendar. If it is triple effect, there will be 3 numbers of calendar so will be used. Okay, now if we use double effect or triple effect, suppose in case of double effect or triple effect, that can be used in different manners. These are forward feed, backward feed, and parallel feed. If we look at this, then we will get multiple effects. Suppose this is the single effect. Now single effect evaporator is this. Roughly, if we drawing, this is the single effect. Now what happened in case of forward feed? This is the single effect, but what will happen? This is the steam. Now this is the vapor. Now in case of double effect, there will be similar type of one calendar will be there, where the amount of vapor which is produced in the first effect is entering into the second effect. This is known as the reuse of the steam, and it is again used. Now whatever the concentrated product that is you are getting from the first effect, that is reused as a feed in the second effect. Okay, this is the one time we are feeding. This is the steam, this is the feed you are feeding. Now whatever the concentrated product, this is the concentrated product you are getting from this. Now this is used as a feed in the second effect, and whatever the vapor you are producing, V1, that is entering as a steam into the second effect. Now this is known as the double effect. Now if we put another effect, then it is known as the triple effect evaporator, because there are 3 numbers of calendars are there. Now similarly, same amount, whatever the vapor which is produced in the second effect, that is entering into the third effect, and we are getting the condensate. Here we will get in the condensate. Here we will getting the condensate. And whatever the product you are getting concentrated with, same thing is used as a feed material, and you are getting the vapor, that is the V3. This is the first effect, this is the second effect, this is the third effect, and from here we will get the final concentrated product. Now this is known as the multiple effect, or here actually 3 calendars are used, so it is known as the triple effect evaporator. Generally in large industries, food processing industries, this type of triple falling film evaporators are used. Why? Because in single effect evaporator, desired consistency is not achieved. Suppose you want 15-degree bricks, whatever I have discussed, to 60-degree bricks. So concentration we want to get 60-degree, because in one effect we cannot achieve. So what will happen? If we want to achieve in single effect, you have to recirculate it. Continuously you have to recirculate, so that you will achieve the 60-degree. But if we want to, suppose 15-degree bricks you are putting or feeding inside the first effect, then it is going to the concentrated. After coming out, it is not going reaching the 16-degree bricks, 60-degree bricks. It will be hardly around 25 or 30-degree bricks. Okay, then it is 25-degree bricks whenever it will be entering. Then what will be the thing? After coming from the second, it will be about 45 or 50-degree bricks, and then it is be entering into the third effect, and again you will get the 60-degree final product. So whenever you will be proceeding from first effect to second effect to third effect, so what will happen? P1, P2, P3, that will be reducing, means P1 will be greater than P2, will be greater than P3. Okay, means P3 will be the maintaining more vacuum pressure inside the calandria. Okay, and whatever the vapor that can be used, or it can be condensed to the water. So this is why it is known as the forward effect, because here feed and concentrated product both are passing from first to last. One P1 and T1 and T2, they will be also, T1 will be greater than T2, will be greater than T3. Okay, means temperature will also be reducing from the first. So this is applicable, and then this is the applicable for generally all types of food, in food processing, all types of food material. Okay, but in case of highly viscous or highly concentration food material, if we want to concentrate, then we have to go for the backward feed. This is known as the forward feed. Multiple effect, but forward feed. Okay, this is known as the multiple effect, forward feed. Multiple effect, forward feed. Now if we go for the high concentration, same thing will be there, but one thing it will be that backward feed. Backward feed, why it is named backward feed? Because feed and steam that will be in different, feed and steam will be operating in the different direction. So backward feed will be backward feed. backward feed will be, suppose if we take the double effect, if we take the example of double effect, here feed is entering, not if we take the steam is entering here, and this is the another effect. I have told double effect means two effects will be there. Now what will happen? Suppose feed is entering from here, from the last effect. Now what will happen? Whatever the product will be getting, that is with pump, it will be entering into the second effect, means first effect, and then we will get the final product. This is the final product, and here whatever the steam, this is the steam is providing. Now whatever the vapor it is producing, this will be entering here. Okay, this will be entering here, and it will be condensate will be getting, and vapor will be producing. So this is the AP is entering, and this is the steam. So from this you have understood why it is known as the backward feed. Backward feed means feed is entering into the last effect. Why it is laughing? This is the first effect, and this is the second effect. Okay, and if we like this P1 and P2, and P1 is greater than P2, P1 is greater than P2, and T1 is greater than T2. Okay, so from low temperature, whatever the product we are getting, that is coming at low pressure because P2 is less, and we are feeding into the high pressure calendaria. So there is a pump should be used. This pump will flow from the low pressure to the high pressure, and finally we will get the final product. Okay, and whatever the steam that is entering, whatever the steam and whatever the vapor that will be producing, that will be entering into the second effect, and we will get the condensate here. All of your vapor will be produced. So this is how what will be the name of this system? This will be known as the forward effect or backward feed double effect evaporation. Backward feed, why it is double effect? Because there are two calendars are used. Okay, so these are the two things. Now I will be discussing how many there are different types. There are different types of evaporators used in food processing industry. There are, if you look at it, suppose there are different types: falling film, falling film, rising film, short tube, long tube, scrap surface. Different of, but among these, generally falling film evaporators are widely used for concentration purposes in food processing industries. Okay, so what are the types that we can discuss by using one slideshow, that is PPT I can share you. This is the sharing So these are the evaporators. If you know, this is the I've told you that this is the steam, this is condensate and concentrated product we are getting. Okay. Types of evaporator: natural circulation, forced circulation, film evaporator, long tube, climbing film, falling film. Among these different constructions are used. Okay. Falling film evaporators are widely used. If you look at this falling film evaporator, you will be looking how it will be looking, that I will be coming in the next class. That is how it will be looking like single effect falling film evaporator. Okay, single effect falling film evaporator will be looking, it is one calendia will be there, a large number of tubes will be inside the calendia, and inside the tubes food material will be flowing, and outside the tubes steam will be flowing. Steam will release the latent heat of condensation that will be absorbed by the surface of the tubes, and surface of the tubes will be heated up. That heat will be transferred to the food material, and food material will be heated up and it will be boiling, as the vacuum will be maintained inside the tubes. So it will boil at low temperature and it will be producing vapor as well as the concentrated product. This is the thing. Okay, so next class I will be showing you how the single effect falling film evaporator working principle. Okay, now I am ending with it. Okay, if you have any question you can ask me, otherwise I am ending with you. Okay, bye.